Welcome to Public Lecture Artificial Intelligence for Public Policy.
Myths, Challenges, and Resolutions. My name is Gloria Choi from International Business Engineering class of 2020.
And my name is Timothy Christian University from International Business Management, Batch 20. It's truly an honor for us to be the masters of ceremony for this event.
We are delighted to welcome you to this event presented by International Business Engineering Program of Petra Christian University. But to start off this event, let us begin with an opening prayer.
And I'll lead the prayer in a Christian way. Dear Heavenly Father, we're thankful for this beautiful day. Please bless all of the participants, the committees, the speaker, as well as the moderator here today. In the name of our Lord Jesus Christ, we have prayed. Amen.
Amen.
Now, today's public lecture has an exceptional theme, which is AI for public policy, myths, challenges, and resolutions. But Joy, can you please explain to us what's the meaning behind this theme?
So Timothy, to this lecture, we'll focus on the new rising technology, artificial intelligence. Some might even say that is the greatest revolution in human history. It is hard to name a sector that will not be dramatically affected by artificial intelligence in the near future. And public policy is no exception. With AI still being fairly new, there sure will be some myths, challenges, and resolutions in the future or even now.
I sure agree. In a world of changing and interlinked policy measures, data science and AI can provide policymakers with unprecedented insight, from identifying policy priorities by modeling complex systems and scenarios to evaluating hard-to-measure policy outcomes.
Exactly. With such potential, this sure can be the game changer in the future. Luckily, today we are welcomed by our expert, Mr. Batarseh from Virginia Tech College of Engineering. But before that, we have some important notice for the audience.
Yes, so please take note that first, all participants have to join with audio. And for those who are yet to connect, the audio will be reprimanded at most 3 times before being expelled from the Zoom by the committee as a consequence. Secondly, there will be a special prize for 3 best questions at the end of the session, and 3 winners will get 100K rupiah each, or the equivalent in dollars. Finally, if you have any problem at registering in or out, you can directly contact the contact person via WhatsApp. And that's it for the short notice.
Now, before we move on to the main event, we would like to invite the head of the Industrial Business Engineering program that has contributed incredible effort to put this event into reality. So please welcome Dr. Indriati Nyoto Bisono.
Okay, thank you, Tim and Joy, for the time. Yeah. Good morning, all. I'm Indri, and it is my honor to welcome you all here today on behalf of International Business Engineering program. The topic of our webinar today, as Tim and Joy mentioned, artificial intelligence for public policy, myths, challenges, and resolutions. It is very interesting topic, don't you all agree? Yeah. Actually, AI is one of our courses here in IBE. In addition to that, we have data mining, business analytics and intelligence, computer science and programming, and we have industrial engineering topics as well. As we all know that in today's digital transformation era, AI will be more and more common, and everyone at least has to broaden their knowledge about AI. And that's why our students has come up with this webinar. I personally thank you for all the efforts from the committee led by Pancha, who has made this webinar possible and successful. And also thank you for inviting our speaker today, Dr. Batarseh. I think Dr. Batarseh is the right person to share to us all about AI, since he led researchers focus on developing AI application and assurance algorithms in Virginia Tech. We really appreciate Dr. Batarseh for your time today. So without further ado, please inspire us, sir. And everyone, stay hungry and learn a lot today. Okay, thank you.
Thank you very much, Dr. Bisono, for the lovely speech. And in the interest of time, next up, we kindly invite the head of event to share a few words. So without further ado, please welcome Pancha Chandra. So to Pancha, the time is yours.
Okay, so hi everyone. First of all, I would like to thank Dr. Batarseh for his willingness to share his knowledge with us today. Dr. Toknomo as today's moderator, and also Dr. Bisono and Dr. Hani Sawandi, and all of today's committee members that had made this event truly possible. As we know, AI is changing almost every aspect of our daily lives. From social media's algorithm, virtual assistant, product recommendations to photography, AI is already being used by every one of us every day. And it has even become an integral part of many people's lives. However, there are still some skepticism and myths surrounding the usage of artificial intelligence for public policy. That's why today's committee members and I are very excited to have the opportunity to arrange today's public lecture and to hear Dr. Batarseh talk about this topic. And I hope through this event, we can all learn many things about the solutions to these myths and skepticism surrounding the usage of AI for public policy. So without further ado, I will give it back to Joy and Timothy. Thank you and enjoy, everyone.
Thank you, Panta, for the welcoming speech.
Now we have eventually arrived at our main event. I believe our audience is already impatient to move on to the main event. Am I right, Tim?
Yes, that's true. And by the way, Joy, I heard that today's speaker is an amazing individual with fascinating experiences and vast knowledge about data science.
Exactly, Tim. So to all participants, if throughout the session participants have any questions, you can type using the right format to a participant named Q&A. So now without further ado, we would like to invite today's moderator, Dr. Kardi Teknomo, and to our honorable speaker, please welcome Dr. Feras Batarseh.
To Dr. Teknomo and Dr. Batarseh, the stage is yours.
Hello, everyone, and welcome to today's webinar. Thank you all for finding time and joining today's webinar. First, let me introduce myself. I am Kardi Teknomo from the International Business Engineering at Petra Christian University this presentation today. I'm glad to welcome Professor Feras Batarseh, who will present artificial intelligence for public policy, meet challenge and resolution. Before we start, let me explain how you can talk to us through during the webinar. If you have any questions during the presentation, please write them into the chat. The Q&A session will be at the end of the to answer your question. Recording version of this webinar will be available in YouTube. Now we can begin. Our today's speaker is Professor Feras A. Batarseh. He is a research associate professor with the Bradley Department of Electrical and Computer Engineering at Virginia Polytechnic Institute and State University, or often we call it Virginia Tech. His research span the area of AI for policy, AI assurance, data engineering, and context-aware software system. His work has been published at various prestigious journals and international conferences. Additionally, Dr. Batarseh published multiple chapters and books. His two recent books are Federal Data Science and Data Democracy, both by Elsevier Academic Press. And now, here is our special guest, Professor Batarseh.
Thank you, Kardi. Thank you, everyone, and good morning. First, I want to thank Tim and Joy for a great for the energy. That was beautiful, and thanks to Andri as well and Kardi for their welcomes, and certainly a big thanks to my friend Hani Suwandi for his invitation and for the connection. I'm very happy to be here. So, good morning, everyone. I will begin by showing the agenda for this talk. We can't talk about AI without talking about data. Data, as some of you might know, is the fuel that pushes learning and it creates learning within an AI system. And however, there has been a recent, as the moderators introduced, there has been a major push. There has been a lot of hype surrounding AI. And in this talk, I want to differentiate between the hype and the hope, right? AI, just like most other technologies, is a double-edged sword that assurance can sharpen that sword and provide a better tool for all of us. However, we have to use it carefully and we have to use it in a way that benefits everyone whom using it. I want to begin with AI in Indonesia, given that the biggest percentage of the crowd today is from maybe Surabaya, maybe from Jakarta, maybe from other cities in Indonesia. And the AI in Indonesia has been prominent, and it's been growing. Indonesia is one of the most countries adopting AI in Southeast Asia. 25% of Indonesian companies have adopted AI within their processes. And the government is pouring a lot of money, almost $366 billion by 2030 into the Indonesian economy. And Indonesia is one of the top Southeast Asian countries to deploy AI. However, the deployment so far has been in specific areas such as education, food security, mobility, and other similar areas. I will talk a bit about food security today as part of a national policy in AI and also policies that drive AI. So, given this rise in interest, you should, as students in the IBE department, you should care about AI. You should think about AI. You should think about data, right? So the data question, right? Let's begin with the data question, and I want to read to you this paragraph that I found in a book, and then I'm going to tell you why this paragraph is very important. Okay, so this paragraph is as follows: day by day, it becomes more evident that the data we happily possess in excellent quality and abundance are the mainspring of modern civilization. Data in truth stand not beside, but entirely above all other commodities. It is the main material of a country and the factor in everything we do. With such facts before us, it can be no matter of surprise that year by year, we make larger collections upon a material of such myriad qualities of miraculous powers. Now, this paragraph sounds like it was written recently, right? It talks about data, it talks about its power, and so on. But what I didn't tell you is that this paragraph was written in 1865, in the year 1865, 1865. But it was not written about data. This was written by this gentleman on the left with the beard, William Stanley Jevons. And he wrote this about coal. He wrote this when coal was driving the economies across the UK, the West, Europe, and other places. Then after that, Milton Friedman, the famous economist, took that same paragraph and replaced every instance of the word coal with the word oil. And the paragraph standed correct for oil, right? So oil and coal were an incremental evolution in energy creation and in driving world economies and countries' economies. What I did today is I replaced the word coal and the word oil with the word data. And that paragraph stood very true. So when I read the paragraph to you, the paragraph did not actually originally say data, it said coal and oil. But I changed that to data, and it sounds perfectly correct to what we envision and what we see today. We're all familiar with the famous statement, data is the new oil, or data are the new oil. The biggest technology companies, all the latest, biggest international deals are all data driven. We can see how companies like Facebook, Alphabet, which owns Google, IBM, all of them, the latest, biggest deals have been data driven, and they're obviously in billions of dollars. And so all those businesses, they've done all those deals because they care about the data and because of technology. Facebook didn't buy WhatsApp for its app; rather they bought it for the data embedded in it. And as we all know, narrow AI has been successful. We have seen applications of AI where in 1996 even, the world's best chess player has been beaten. In 2016, the world's best Go player has been beaten by a trained AI. So we understand that narrow AI works successfully. However, what we don't want to do is not to use AI across everything and for everything. AI is a big, heavy tool. We don't want to hit a nail with a sledgehammer because currently the term artificial intelligence is certainly overused and it's underdefined in many contexts. And nature and the world is fighting back. It's fighting back technology, right? Technology is invading us in so many different places. but the world and our human nature and the world's nature is fighting back, because without assuring those systems, we are doomed to fail, and we are doomed to use them in many ways that are not good. So with that background, I want to get into, and before I get into applications of AI for public policy, I want to give you more motivation on existing AI myths, right? If you search the internet or search any library you go to for different definitions of AI and different solutions and powers of AI, you will see many different definitions and many different uses of AI. But there are certain myths that we have to debunk as a scientific society to be able to proceed with AI carefully and to be able to accomplish AI that benefits the social good. The first myth I want to address is that AI is everywhere, right? Anywhere you go now, most companies, marketing companies, software companies, they all use the term AI, obviously overusing it, in many cases, replacing cases such as data science or machine learning or big data, right? There's many words that are being used interchangeably. AI, however, and based on a recent definition by the AGI conference, which is the Artificial General Intelligence Congress conference meeting that meets once every 2 years, AI is a set of adaptive systems and agents that have the ability to perform intelligent tasks in complex environments. That definition has been attracted by the famous Alan Turing paper, where he introduced his 9 objections to AI. Alan Turing's Computing Machinery and Intelligence. I recommend this paper to all of you if you have interest in this field. I think this is a must-read. The paper presents what Turing calls the 9 objections. AI has theological objections, and we saw Tim, starting this Zoom with a prayer. There's a theological objection to AI. There are mathematical objections to AI. There are arguments from consciousness and many different other objections, including the famous Lady Lovelace's objection that states that creativity from a machine is impossible, until that notion was valid from the 1800s up until 1950, where Turing designed his Turing machine and was able to show that machines can actually present or create new forms of thought and so on. So we want to be careful with the notion that AI is everywhere. That's a myth that has to be certainly busted. The second myth is that numbers don't lie. If you present numbers, then that kind of basically ends the conversation. It's all the facts. The issue with that is let me move this somewhere else. The issue with that is that Kurt Gödel, a famous scientist, he presented the incompleteness theory, and in the incompleteness theory, it was the first wave from a series that challenged formal systems. Call it a school of thought, or an anti-school of thought, basically, where Kurt Gödel claimed that math is incomplete. The entire mathematical system is incomplete. Other examples to such theories included Turing claims on the halting problem, Einstein relativity theory, Heisenberg's uncertainty theory. Such theories run very well within a scientific, folklore, and they have high popularity and so on. However, Kurt Gödel's theory is important in the context of AI because the theory established that through mathematical proof, mathematics could not prove all of mathematics. Meaning that there's many pillars in math that are not able to be proven. Many basic constructs in mathematical design could not be proven by math through its incompleteness theory. Another lighter version of that theory is a book that I'm a fan of, called How to Lie with Statistics. This book presents many different forms, and that's another book that I also recommend that you check out. You'll find it online for free. It's an old book. It shows how certain paradoxes, such as, for instance, the Simpsons paradox, does not give you an assured set of results. Rather, what it does is, depending on the way that you slice and dice your data, you can get results that are biased towards one or the other, desired outcome. In this table, for instance, we're looking at the same data for Democrats and Republicans, for instance, in the US. And as this data is chunked differently and sliced and diced differently, we can get different percentages showing who's getting more percentage of the votes and so on, which is obviously something that statisticians can override, but often, with policy making and other areas, those assurance checks are not comprehensively addressed. There are many other issues within the learning and the data science, the life cycle, where you interact with overfitting of learning or underfitting of learning of the data set. And then there are many adversarial attacks, obviously, that occur across many occasions. For instance, if you look at this image in the bottom, the image on the right of the actor and the image on the left look exactly the same. However, the difference between them is that there's an adversarial noise that's been added to either one of them, where the machine learning algorithm will not be able to identify that image due to that invisible adversarial noise, right? So there are different levels of data assurance and AI assurance problems that occur in this field. And this is the cover of the book that I mentioned, How to Lie with Statistics. It talks about multiple different bias, skew, and outliers and data imbalance and other issues that I certainly recommend. So there is a statistical myth that has to be debunked. There's an AI definition myth that has to be debunked. And the third one is, in my opinion, the most dangerous one. Experimental science. We see out there's so many ways to publish science. The main method to publish science is by peer reviewing others. You submit a paper, it gets peer reviewed, and it gets either accepted or rejected, and eventually becomes part of the body of science. Now, the issue with that is that there's a serious crisis in scientific publication and peer reviewing. If you're familiar with this gentleman, his name is Aaron Swartz. And this was a movie about his life. Aaron Swartz, what he did is he wanted to make science open to the masses, to everyone in the world. And so what he did is he was an MIT student. He collected all the papers and books that MIT library has. And when you're a student in the US, you get access to all public universities and all public libraries, all public repositories of papers and publications and conferences. And so what he did is he wrote code to collect all of that and provided that on a public repository for everyone online to access. He was persecuted. He was fairly persecuted, and he was guilty. And so he was going to be sent to jail. But before that happened, due to the constant pressure from federal agents and from the country and other beneficiaries like the publishers, Springer, IEEE, and others, he committed suicide. So it's a very sad story, but it's a very important topic. And one of his most prominent outcomes was the Open Access Manifesto. Aaron Swartz wrote the Open Access Manifesto, which I have a screenshot of it here, but I recommend that you also read it and take a look at it. The Open Access Manifesto shows that science and data, right, should be shared across the world freely. And the reason for that is because many of the scientific studies that are published, that we base our knowledge on, and that we base the body of science is built upon, is highly debunkable. So in a recent study by Nature, 65% of studies in the medical field that are published in Nature could not be replicated, which is a very dangerous aspect. And that is due majorly to data. See, all of those different angles that I'm presenting are all relevant to myths related to data. And if data that feeds the learning algorithms that create the intelligence in AI is biased, or it's inaccurate, or it has replicability issues or any other issues like that, then the outcomes of AI will be inaccurate and will be dangerous to all of us as it's getting applied to many domains such as education and policy and all other domains. And so there's a serious crisis in the scientific community about the accuracy of such publications, which is another major myth that I would like to present. And And I think one of the solutions to this would be the sharing data across multiple platforms, creating an open data manifesto, just like Ernest Watts presented. Now, there are some silver linings. There are a few places where that's the case. There's many open source libraries, many open AI libraries out there, open data. Most cities now have open data, and even different countries within different regions share data with each other to optimize and to maximize benefits of citizens, the economy, and so on, which I'll show some examples of that today. But there's still a lot of work needed. So all of that shows and illustrates the importance of data, the importance of AI, and all the myths that exist. They illustrate the need for AI assurance, specifically in areas like public policy. And I will get to policy in a second. But we know very well that we can sort and we can classify images, right? At this point, deep learning algorithms can very successfully classify images. However, there's still many blind spots where an example like this one, I mean, it could be offensive to some, it could be funny to others, but it's really AI methods fail to detect the difference between certain things that could be absurd to a human being, right? Human beings were easily able to identify such aspects, but an AI algorithm is still can fall short with such very important differentiators. And so jumping from those images to the importance of AI and the need for AI's need for assurance in policymaking. If we just establish that data validation, availability, and bias are major issues in AI, there's also most policies all over the world, in Indonesia, in the US, in Europe, in the Middle East, anywhere you go, policy is mostly based on heuristics, experience, opinions, even in some cases corruption, right? You can think of all the different ways that policy gets created around the world, none of which are very data driven. Some obviously are, but not to the extent where causation, counterfactuals are studied, not to the level where you can create country specific policies, right? So Indonesia's policy for exporting a certain commodity to other countries in Southeast Asia is a blanket policy that applies across multiple countries, for instance, in many cases. The US's policy in exporting beef to countries of South America or North America or Europe is also very rarely specified by commodity and by country, which is something that AI enables us to do. I'll talk about the Lucas critique as well, which basically illustrates that policies are made by humans based on experience and only based on experience and opinion. So if we begin with opinion-based policy, which is the first circle in the bottom, this was based on a project by some of my students, and if we begin with opinion-based as the first part of technical capacity in policy making, then we can move to evidence-based, where you have evidence and you take decisions based on evidence. That sounds a little better. But then if you get to a data-driven level, where you're actually collecting data from multiple areas and you're making decisions based on a comprehensive data collection process, you'll get a much wider lens onto your country or your specific policy area that you're trying to accomplish. But then finally, the fourth level that we are trying to introduce is AI-influenced policymaking, where you use intelligence that is automated, that consumes big amounts of data and learns from big amounts of data to create policy processes. So we all know what happened with COVID. During COVID, the world economy stopped in so many different ways. Many predictions were not able to predict number of cases or what's going to happen to the economy, how certain commodities are being traded across different countries, right? And that is because most of those models do not consider, for instance, outlier detection. They don't consider outlier removal, or they don't have ways even to measure counterfactuals and causal analysis and correlations and associations between the event and what it causes to specific commodities. It's also mostly because the data is not available and the big data is not structured in a way that allows for such an outcome. And so COVID was another red flag on this issue, showing that policy and data predictions that we have are very, very, very weak, especially when they're faced with any kind of an outlier event. They completely change course and they become basically pointless. And we'll show some numbers that are similar to that. Also, applying public policy across any country in the world is not precisely a straightforward action. Just like the 1990s with the tobacco issue, in the 1990s, the US government would subsidize, it would spend money on subsidizing tobacco farmers, right? Because tobacco was being farmed and that needed to be subsidized to support the farmers. But then the government would spend more money on funding health programs for respiratory patients and for patients that have been smokers and so on, even spending money to ban smoking and for campaigns on smoking. So you're spending money on both sides of the spectrum. And the same thing is happening with data. Data governing bodies now are pushing regulations that are basically opposite to each other. The funding and work allowing for tax cuts and tax budgets for companies like Amazon and Facebook and so on. At the same time, fighting for data privacy and data and the citizens' right to internet freedoms and digital freedoms. So there's a huge contradiction in those two directions. And that is certainly, eventually harms the consumer. It harms all of us. It harms, our data privacy, the data we share online, on social media, on TikTok, on whatever social media platform you're a fan of. All that data is being captured and collected, and most of the time used for marketing purposes that do not directly benefit you, but benefit profits and so on. Okay, so with this background and with all the challenges that are presented, let's now talk about a specific policy scenario. The specific policy scenario I'm going to cover is for AI for public policy and economics, and with it touching on international trade policies. This work has been published across multiple venues. It was presented at the National Bureau of Economic Research in the US. It was published by the Federal Reserve. Some of the work is implemented at the United States Department of Agriculture and also the Association for AI, which is Advancement of Artificial Intelligence, another top venue for AI in the world. So this work has been majorly recognized, and we try to address, my students and I try to address three main questions. And I don't want to fail to mention that this was also done in collaboration with other universities like University of Georgia and faculty there and so on. But the three main hypotheses that we aim to answer is that trade patterns across the world could be predicted and with better accuracy through AI when compared to traditional econometrics. That's the first question we wanted to answer. The second one is that trade transactions can point to county commodity associations, meaning, like I said, you can identify policy that are specific to a commodity and specific to a country, without having corporate blanket policies where you present one policy for all countries and all commodities and so on. AI models also can mitigate uncertainty, and this is the third question that I'm going to point to today. And very importantly, this is a very important part where you want to understand causal implications during outlier events and also during conventional events. Like I mentioned, what happened with COVID, which commodities are affected the most, which commodities are not affected the most, and so on and so forth. To that point, and to the policy of agriculture and trade in the world, I want to begin with this very famous legal case in the US, Wickard versus Filburn. Filburn was a farmer in Ohio who was farming different commodities like soybeans, wheat, and so on. He started overproducing so he can use some of his crops for feed, so he can feed his cattle, his cows, and so on and so forth. Now, when that happened, the prices, as you know, when there's an increase in production, there's a maybe decrease in demand in many cases, where the price then will also go down. So the prices of wheat in that case dropped in Ohio and surrounding states, and then eventually in the country. Other farmers started complaining that Filburn is manipulating the prices because he's overproducing his commodity. And this case went all the way to the Supreme Court, and it was eventually it was ruled against Filburn, and it was The outcome was that the government can control how much of your land you can assign to wheat or barley or corn, and so on and so forth. And so that was the beginning of the U.S. government interfering, if you will, in the decisions on the farm. So now we can see that production on the farm and international trade and prices and supply and demand and all the different variables, they are connected with each other, right? And so if you're producing more corn, then you have more supply, then the demand is going to go down. And so, it's this whole economic equilibrium balance that needs to occur in the country to make sure that the prices are controlled and the trade is controlled in the right way, which is a direct implication of public policy, right? On the country and actually on the world as well. And we'll show some examples of that. The Chicago Mercantile Exchange produces futures on trade of commodities. It predictions of prices, production, utilization, consumption. It shows how the supply chain in the US looks like for agricultural commodities, and it presents those predictions, right? And those predictions, just like the stock market, it presents those predictions that would then allow farmers to make decisions, allow supply chain producers to make decisions, allow policymakers to take decisions, and so on. However, based on our study, we realized that those numbers are so not very accurate, and I'll show some examples. So what we did is collected data into many of these open source technologies. We used Python, R, Unfolding, Tableau, and other technologies. And what we did here is that we collected data from multiple sources, including USDA's Foreign Ag Services, Yahoo Finance, economic indices, and we'll go through that in a second. Data from the Global Ag Trade System, World Bank, the Food and Ag Organization of the United Nations, the World Trade Organization, the World Bank, and many other organizations. So what we wanted to compare it against is gravity models. Gravity models are basically models that govern international trade. Historically, it's a very simple model where you can think of a big country and a small country. The bigger the two countries are, the more trade there is between them. The closer the two countries are, also the more trade is between them. Distance affects trade negatively, and size of countries affects trade negatively. The smaller, the less trade, and the more distance, the less trade. That's really the basic idea of a gravity model between two countries. Now, in the US, for instance, and many other places in Europe and across the Western world, in this example, the Ag Outlook reports in the US were less than 35% accurate in the third quarter of the year. And so it would take for 3/4 of the year for the data to become 90% accurate, which at that point would be too late. So only after having actual data for 3/4, the data can get to a level where it's dependent. So there's a major lack in long-term predictions. There's no guidance during outlier events, and there's few variables only being considered. What we did, and to mitigate a notion called dark data, and I'm not going to go too much into the idea of dark data. I invite you to read about it. It's a very important idea. We wanted to mitigate the effect of dark data, and so we collected as many economic variables as possible from all those sources. We measured distance, population, GDP, population, colony, land, whether the nation is landlocked or not. In the case of Indonesia, it's an island. We wanted to capture that as well. What's the language? What's the FTA agreement? All those different variables we tried to capture and in our data set. And so we collected all this data, and we started doing this for certain commodities. We began with the major commodities in the world, such as beef, wheat, barley, and so on and so forth. And we began by basic regression algorithms, and we then migrated to ARIMA models, which are autoregressive moving average algorithms that give you a confidence band for production. So we started moving trying different models. Those are the models that are used by, for instance, USDA, where you have simple line predictions that extend towards the future on what the amount of production for a certain commodity could be. So as we moved from regression to ARIMA, we saw that the quality of the outcomes, and we also tried decision trees and other boosting algorithms, and this is some of the formulas of those statistics that we used, we realized that the results are still fairly weak. And although we were able to get some good results based on for specific commodities, but boosting didn't give us good results. We trained data from 1960s on, and for all commodities. And as you can see, we started digging deeper into trade between two countries using for one specific commodity, for instance, Australia and Japan for beef, US and Japan for corn, and so on. But we were not so happy with the results. However, when we applied deep learning, when we applied neural networks training on the data set, we started getting more accurate results. In many cases, we got very good predictions for certain commodities. For instance, for US soybean exports, we got the good predictions from years 2017 onwards. For rice exports, we got the predictions. For corn exports, we got good predictions. And so we noticed that deep learning can do a better job at understanding those trade patterns, because all this data that's being consumed by the algorithm, it doesn't have a clear-cut trends, right? If you think of a regression model or any other model, if you feed it one or two variables, it's going to give you a good line of fit. But for deep learning algorithms, when you feed it this much data, if you pass that to a boosting algorithm, maybe it's not going to be able to identify all the different patterns found within the data set, while deep learning algorithms have that ability. And so we were able to successfully do that, which is good, but we were not satisfied. We wanted to dig deeper and do more in this. So what we did after that is we started clustering countries by their size of trade. We looked at countries by how much trade they do within specific commodities, and we ended up with 6 clusters. And we realized that when we do those 6 clusters, and that was the best, we used we tried the k-means, we tried silhouette coefficients and elbow diagrams to come up with the best clustering aspect. And we got the best one was, let's say, for the entire world, countries of the world, was k equals 6. This is a subset of that. But we realized that, for instance, countries in cluster number 1 are the biggest traders in the world, like Japan, USA, and so on and so forth. Then we have countries in cluster number 5, which are like maybe the second biggest, where, for instance, Indonesia falls, and other big countries like Brazil and so on. And so we realized that if we only used clusters such as 1 and 5 for the predictions, for the classification, we will get better predictions overall. So that is referred to as ensemble machine learning, where you take an outcome of a model and you feed that into another model. So an output of machine learning model 1 becomes an input for machine learning model 2, and then you get the output that you desire. That way you're optimizing what's going on. You're optimizing the process, and you're optimizing what you're doing with your analysis. And so when we did that, we realized that the amounts, the amounts of split and gain, which indicate the importance of a variable in your algorithm, have increased drastically, and that we get, it's pointed us to variables like distance and GDP of the exporter as the 2 most influential economic variables for prediction of trade quantities and between the nations. Time, such as time variables such as year, was also very influential. Population was a major driver, and currency as well, where it was a major driver. So why should we care, right? How is that relevant to policy? Well, if you are in New Zealand and you're exporting milk to other countries, you want to then identify which countries, for instance, have the highest, for milk, you can see that which countries have the highest GDP, right? Or which countries have the highest population. However, for corn, you want to look for something else, right? For corn, you want to be interested in distance, or maybe you want to be interested in language, right? So public policymakers, based on country commodity pairs, right, can identify now, using this ensemble machine learning process, they can identify which countries they can target and which countries they can do more trade with based on those models. Because this doesn't give you a prediction across all countries or all commodities. It pairs countries and commodities and provides you the most influential variables that drive that specific commodity. Now, while all industries have been seriously affected by COVID, for instance, food and ag have been the hardest hit segments of the US economy and many other economies in the world. The primary reason for that lies in the composition of food expenditures, and the impacts of the pandemic appear to vary by commodity, right? So based on two main factors. Some commodities are perishable, right? Milk, beef needs to be frozen when it's shipped. Wheat, for instance, does not. Some commodities need more labor than others. And so perishables like milk are among the hardest hit because such commodities require instant port access, they require faster shipping, and so on and so forth. And so specialty crops like corn depend on labor for growing and for harvesting and so on. And so the difference between those two, when you're applying policy, you can't define policy that's not commodity based or that's not country based. And by looking at this number of data variables and by looking this far back into the past, you can present a much better predictions and therefore provide much better policy outcomes and have more food security to the country, have more economic a more positive economic effects on the country, and so on and so forth. So this obviously has massive effect on many different sectors of economy and the well-being of the citizens. So although we got those good results that were very policy relevant, we still were not satisfied. We wanted to even dig deeper, and we wanted to look at commodity pairs. So if you go to a supermarket and you see, at least in the US, you see that cornflakes or cereal is next to bananas and strawberries and milk, right? That's because those are often bought together. Now, you understand that example because you know that they are bought together. However, there are many famous other examples like beer and diapers that, analysis showed that they're bought together, but that's not an obvious coupling of two commodities. There's a famous story that garnered national attention in the US. It began with an irritated father entering a Target in Minneapolis, talking to a store manager, complaining about the store sending his daughter a sale booklet for baby clothes, cribs, and diapers, and all other pregnancy items. Even though that the daughter was still in high school, right? So shocked and surprised, the store manager apologized, and the father received a call from the store manager, which was Target in this case, apologizing for what happened. However, the father at that point replied and said, well, there has been some things in my house that I'm not aware of. My daughter is pregnant. So the moral of the story is that Target knew that this teenage girl is pregnant before the girl knew and before her parents knew. And how, you may ask, how did they know that? Well, they know that based on a model called association rules, where certain buying patterns of an individual are affected by, reflects what they're going through, reflects their interests, reflects, in this case, whether they're pregnant or not, reflect their age, and so on and so forth. There are so many associations, if all that data is used, there's so many associations between different variables that can lead to an identification of a certain variable. And so in this case, association rules point to such outcome where the math or the model would know before the human being does. So association rules are applied across multiple e-commerce. If you shop on Amazon, you can see that you're always recommended new items and so on, and that's the same reasoning. Now, this is some of the math of association rules. What we did in this case is we wanted to see how international trade is also affected by association rules. What commodities tend to go well together in international trade? Something that was never been done before. So we started coupling commodities together, and we realized that, for instance, oilseeds, countries that trade oilseeds also tend to trade cereals. Countries that trade animal and vegetable fats and oils also tend to trade cotton among each other. Countries that trade vegetables also tend to trade sugar, and so on. So why is that important, right? You may ask, why is that important? Well, we looked at a specific policy story. Top 10 commodities between China and Australia, right? You know, where Indonesia is right between those two countries. So you have China and you have Australia, and we have tariffs were imposed between those countries, right? During COVID, Australia accused China of originating COVID and creating the disease and so on. As a retaliation, China placed tariffs against Australian barley and restricted import of Australian beef as an apparent, retaliation of the government echoing the calls for international community to investigate Beijing's response to COVID-19 and so on. Now, that policy was never evaluated this way, but as we run association rules for it, we realize it confirms that the choice of commodities that China took were reasonable choices. China, the choices for obviously for Chinese economy, because beef and barley, as they import from Australia, are not the top in the top commodities that are most impact the overall Australian Chinese commodity trade flows. So if you take out barley and if you say, I'm not going to import barley from you anymore, or I'm not going to import beef from you anymore, the Chinese economy is not going to be affected that much. Other commodities like maybe cereal, maybe rice, right? If Australia stopped taking rice from China, then, or vice versa, right? If citrus fruit or any other melons and so on, if China does not import that from Australia, right? Then that would be a bigger hit on that. So this type of association of commodities allows policymakers to make choices on which commodities should go from where and to where and so on. Now, I'll show more examples. As you know, there are in certain instances, there are major outlier events that will also affect international trade. So as summary for the agricultural trade numbers, we were able to accomplish 73% accuracy for sugar, 88% for beef, and so on and so forth. Again, compared to USDA's 35%, that's obviously a huge improvement. However, we wanted to then study the effect of outlier events and given all those different variables. When an outlier event happens, how do you understand, how do you correlate, and how do you provide causal analysis on what an outlier event would create on your trade and which commodities will be highly affected? If you assume that all commodities will be affected equally, or your economy is going to be affected, then that's it. Or there are very few methods that can actually point you to understand fully what's being affected, how, and what's the cause, right? AI can provide tools that can point to that. And so a group of my students did this study, and they looked at economic indices such as S&P 500, Dow Jones, and others like oil and gold, and VIX. VIX is a volatility index that also drives the economy in so many different ways and reflects, how the economy is doing. We wanted to look at this by commodity. So we correlated and created causal analysis between those indices and every commodity, because we wanted to point to which commodities have the highest correlation and causation with which economic indices, right? So, and then those decisions could then trickle down to the farm, where farmers can take decisions and so on. So we built different models, and just like we always do, and that's the best practice. Whenever you're applying machine learning or AI algorithms, you want to try different models. You don't want to try one model. You want to see how different models function, how each one of them, what kind of results does it provide, and you want to compare those results, right? So we tried with different models, and we then did the same thing. We did commodity-specific learning, right? To that point, we made sure to study the causation between the commodities, as you can see on the top right image, the red, green, and image. We can see, for instance, that a commodity like beef has very high causation with Dow Jones. A commodity like ducks, for instance, have a high causation with the S&P 500. But beef does not have a causation with the S&P 500. The causal analysis between them is very low, right? So if the trade of beef changes, S&P 500 is not going to change. And if the trade of S&P 500 changes drastically, the trade of beef is not going to be affected, right? So you follow those indices and you understand this coupling mechanism where you can see the effect of one commodity over one economic index and one economic index over one commodity. The table on the left also shows the correlation between those numbers. After understanding that, we wanted to then provide to a policymaker, right? If you're a policymaker in Indonesia trying to understand how COVID is affecting, oil in Indonesia, right? You want to see that the amount of trade and imports and exports of oil during outlier events and during non-outlier events, during conventional times, if you want to call them, right? So you need two predictions. You don't need one prediction. Most government agencies will create one prediction. It's like next month or next year, we think that this is going to be the amount, this is going to be the price of. So So what we did in this case is that we presented multiple different predictions by coupling the commodity with its highest correlation, as you can see in this table, with outlier events data, with weather data showing hurricanes and outliers and storms, with political outliers, with economic outliers, all fed into this model with the production data of that commodity to create two kinds of predictions, one with outliers, as you can see here, and one without an outlier. So if you're a policymaker, you'd say, well, COVID year was an outlier year. Let me look at the prediction. And let me look next year, if we have an outlier of some sort, this is a prediction. If we don't have an outlier of some sort, this is going to be the prediction. And we call the system Deep Ag, from deep learning and agriculture. And we did achieve very good results for most commodities. Most commodities had specific and good outcomes for outliers and on other slightly different predictions when outliers are not considered, which is basically what we anticipated. Now, if you understand the causation between what would an outlier event do to a commodity, right, and the correlation, that's great, right? But then the next step after that is a prescriptive analysis where you want to say, well, if I increase the production of wheat or barley, what would happen to my trade, or what would happen to my prices, right? So you want to study different counterfactuals. And I'm not going to go through the math of this, but we used graph neural networks to understand counterfactuals. And this is a visual of what we did there. So this is a network of all the countries. This is a trade of soybeans in the world. And you can see Indonesia here in the bottom, right? Indonesia has a trade of soybeans with the United States, for instance. What we did in those three cases in the bottom, you can see that in October 2018, January 2020, and April 2020. October 2018 was before COVID, January 2020, obviously during COVID, and then in April 2020, also during COVID and during trade war. What we did is we would remove a link and study what would the counterfactual analysis do to that trade movement between those two countries. And you can see the thickness of the lines represents the amount of trade between those two countries. The length of the line represents the distance between them. And then what we realized that, for instance, obviously what happened in the trade war is that the US stopped exporting soybeans to China. And China stopped importing soybeans from the US due to trade war between those two countries, right? So what happened is that due to that, the US diversified the exports of soybeans to many other countries. One of them is Indonesia. As you can see that the line has thickened over time, and other countries, including India and many other countries, right? So the benefit of that from a policy perspective to the US was diversifying the number of countries that you export soybeans to. However, the benefit then you can see that only an AI model can tell you and can show you that a country like Brazil was also one of the biggest countries that advantaged from this, because Brazil is the second one of the after the US, it's one of the top countries creating soybean. So China went to Brazil to get its soybeans. And so luckily for Brazil that year, Brazil exported lots of soybeans and obviously made good money from that. Now, the issue there is that you can also think of Brazil's weather fluctuations. Brazil's soybean production is not that dependent because it depends on certain weather patterns that are much less consistent than the US. But during the year of COVID, luckily there was no weather issues, and so Brazil was able to create soybeans and export them to other countries. And so using such graphs, we can understand that not only the predictions are better, not only that we understand that dark data as an issue is mitigated, but we also provide multiple predictions that are created based on the existence of outliers and during the non-existence of outliers, and also understanding causation and the counterfactuals between commodities and economic indices and so on. Now, when you apply this to a legal situation, you can see that understanding such policies, and this is the last section of the presentation, understanding these policies provides an effect on society as a whole. It's called the far-reaching arm of law. Law reaches everywhere, right? In society, it has effect on many different branches and areas of society. And so what we did in this case is we wanted to now then use a different method. Take textual legal scripts and analyze them and explain them, provide explainability to their attribution and their effect on society, right? So if you change a policy, how does that affect society? How does that trickle down onto society, right? And in this pipeline, what we did is we used NLP algorithms and natural language processing and KNN labeling. We used algorithms like GLOVE and term frequency, and also deep neural networks to understand when you change a policy, which aspects of society get affected most, and that's using attributions. And so I'm going to give you a quick summary of this, but this is an ongoing study that my team and I are doing. However, it shows that, for instance, we looked at some laws in Virginia, Arkansas, Minnesota, California, and other states. And what we did is we study the change before the policy is enacted and after the policy is enacted, and how that policy affects certain relevant aspects of society. For instance, if you ban a certain type of commodity production on the farm, or if you ban a certain type of, if you increase number of your bandwidth availability in a state, right? How does that affect desktop use? How does it affect laptop use? How does it affect, education? How does it affect agriculture? How does it affect many other different variables and other environmental variables, as my students call them, environmental descriptors in society. So we saw that, like I said, this is sample different laws that can connect, and we can see how they affect society and how they affect different variables in a state and so on. So the far-reaching arm of law affects society in so many different ways. The methods and the models that are presented here, that were all based on machine learning, deep learning, AI, and different terms and different models, they not only affect policymakers, but it also affects farmers. If you're a farmer and you know that there's an outlier event that's going to affect the production of milk, or the production of wheat, or the production of whichever commodity you're using, right? Using those assurance measures that we presented and some of those, like country commodity, aggregating the data in a way that presents a cleaner results, assuring the outcomes using improving data availability, improving data collection, collecting more variables to present more clear and more precise outcomes. We can see that such policies affect society as a whole, and specifically to farmers. There's a major movement in many countries now to inject more intelligence to the farm based on those policies, to create more food security, and then to eventually create a better economic situation in the country. And so it's really a connection of different areas of society and different segments of society that are affected. If we begin with the right policy, you're going to affect the farmers. If you affect the farmers, you're going to affect the prices, and so you're going to affect the consumer and the consumption cycle. The supply chain is going to be majorly affected across the world, and as we saw, trade gets affected directly by such policies and by such outcomes and predictions, which also leads to all kinds of international relations and so on. It's all one big network that if you nudge it on this side, it's going to move on this other side. And so it's important to understand that we need data-driven policies, because those policies could be fact-checked. They could be used as benchmarks, and they could be used as a foundation for very accurate outcomes that benefit your country, that benefit your farmers, that benefit and really eventually all humans after all. And so we were trying to deploy some of those technologies on the farm. Those are some figures of my students and I at different Virginia farms. We're trying to fly some drones, or we're trying to collect data and optimize and working with farmers to optimize production, optimize how farming can be improved. We call that smart farms at Virginia Tech, and we're trying to create all of that. We have the Center for Advanced Innovation in Agriculture, which drives the innovation in agriculture in the state, the university. Also, the Commonwealth Cyber Initiative, which is a state initiative to make the state of Virginia as a center for excellence for cyber and AI assurance and other areas that we're using all those vehicles to create this movement of AI-driven agriculture, AI-driven public policy for the betterment of this area for the country and eventually for the world. So lastly, if you are interested, I would like to invite you all to join the movement and in collecting better data, creating better models, and using AI for the betterment of societies and humanity in general, and not for any other unintended consequences that we might all suffer from. And with that, I thank you. Those are the two books that were mentioned at the beginning of the talk. I would be happy to send e-copies for anyone who's interested. Please, this is my email. Feel free to email me as well. Thank you all, and I would love to take any questions and discussions. Thanks.
Thank you very much, Professor Batarseh. I hope you all enjoy this amazing presentation. It was new insight that you turned to that given policy. Now, Professor Batarseh will answer some of your questions that you have sent us during the presentation. We have already many questions. I'm not sure if we may be able to answer all of your questions. So the first question is from Veriona Ayurista Elias. So here's the question. We all know that the Industrial Revolution has increased significantly starting from Industrial Revolution 1 to 5. Okay. So the question is, in this era of Industrial Revolution, there are a lot of robotic machine AI technology that work almost in all aspects. Then how do we as humans to optimize the potential that exists within us so that we are not replaced by all this advanced technology?
Yeah, so I mean that's obviously a big debate, right? That's a big debate in the rooms of AI conferences and other places. In the recent survey paper that my team and I published, one of the main pillars of AI assurance is ethical AI. Ethical AI potentially addresses this issue, and as Nick Bostrom in his book Superintelligence called the challenge of value loading. How do you load ethical values into your machine learning or AI algorithm? We're developing methods, and I invite everyone else to kind of focus on this question as well, because it's a very important question. Methods ought to be developed to load values into the learning algorithms so that the algorithms learn with ethics in mind, not as an afterthought, but as an incremental part of the process where ethics are incremental. Now, how do you inject ethics into a learning algorithm? That's the quantitative and the mathematical challenge that is yet to be resolved. But I think, at this point, the worry is not that robots will replace us or anything like that. The worry is really using data and AI for purposes that don't directly benefit us in so many different ways and abuse our freedoms and our digital freedoms and our privacy and so on and so forth. I think those are more timely issues than worrying about robots taking all over the world, because if that even happens, it's going to happen in the long future, and we have time to still think about how to inject ethics into such algorithms, which is something that's ongoing in many venues. But yes, that's an ongoing discussion, and I thank you for that question.
Yes. The next question is from Emmanuel Sibarani. So he's asking about the security aspect. When humans create public policy, they are often influenced by entity with personal interest. What about AI-based public policy making? Can they still be influenced by external entity? What if the data is manipulated? Don't we need cryptography for security for application of AI?
That's a great question. That question is at the heart of this presentation. The quality of as we call it GIGO, garbage in, garbage out, right? The quality of the data affects the outcomes of the algorithm, obviously. And so checks and balances, and that's really the essence of AI assurance, checks and balances on the data that would prevent its bias, its incompleteness, and all those different statistically identifiable challenges are resolvable from data. However, the big issue in similar to what you said in your question, the big issue is in other entities interfering in data creation, data collection, a bias in data collection and creation, and like I initially indicated, in many cases, corruption in those data sets. And so we've been calling for open data initiatives. Data openness allows the public to look at the numbers as well as the policymakers to look at the numbers to create policy that's more transparent and accountable. In my first book, Federal Data Science, I present ways to support open data. And other authors and myself, we review open data across the world in China, in Southeast Asia, in Europe, Canada, US, and other places in the world where data openness could be one way to ensure transparency and reduce levels of corruption and interference, as you pointed. So I hope that answers your question.
Yes, there are several people asking almost similar question here. So in today AI technology that work in almost all aspects, what happen if AI take the job that means for human? And what will happen if we are over-reliant on AI in our everyday life?
Yes. So being, having a big number of students in this room, I want to break the news to you. AI will take many jobs. That's inevitable. Just like the Industrial Revolution took away many jobs, just like any technological advancement replaces certain jobs. The advice for everyone is build skills that are irreplaceable by a machine. Work on yourself. Try to develop as many skills as possible that are irreplaceable by simple statistical measures or by algorithms, right? There's always going to be a human factor that's going to be needed in many areas, in many domains. And if you work on yourself, if you build yourself, if you improve your skill and skill set, then I don't think that you should worry about that. But most routine jobs will be replaced by an algorithm. And if you're doing a routine job, then you're not working hard enough. You should try to develop skills that are intelligent, that are relevant to the world we live in, and also make sure to learn AI as well, so you can be relevant too.
Right. So there are several questions almost similar again. As we know, AI is a human mimic. It can think and memorize just like human. However, we know that human cannot memorize clearly about what happened to them 10 years ago or more. But nowadays, computer can memorize with unlimited amount of storage. So do you think AI will be better for the future than human?
Yeah, so at this point, AI can memorize better. It can look into the past and predict and learn from much more, longer events in the past. However, we still don't know how AI can provide, understand its context, right? Understand many aspects of causal analysis, having relevant reactions in very complex situations. There are still AI still have many advantages, and I encourage you to read about contextual reasoning. That's an area where the AI society is still seriously suffering in, because most learning algorithms do not understand their context. The algorithm does not have self-awareness. It doesn't know that it's intelligent, right? If we are saying something or doing something intelligent, or if we're working hard, you know that you are aware. You know that you understand the context. The machine is not self-aware, and therefore, I think that obviously until this day, humans are creating AI. We are building algorithms. We are building intelligent algorithms. Again, there's no worry at this point today on whether algorithms will take over and everything else. However, make sure, like I said to the previous question, empower yourself and make sure that you have enough skill set that can guarantee that you're not replaced by an algorithm if you're doing a routine job.
Yes. In relation to that, there is a question about, can AI gain conscience?
Yeah. Well, you say, can it gain conscious? And as a scientist, I want to tell you everything is possible. But at this point, it's not possible, right? At this point, AI does not have conscious, and like I mentioned, doesn't have self-awareness. But I think that's something that's being worked on so many fronts, in so many places. The psychology of AI and the brain interfaces that are being developed can eventually lead to something like that. So instead of fearing this change, join the revolution, join the movement. Be part of it, and maybe make Indonesia one of the top leading countries in this area. I think that would be the best approach to dealing with this issue. So if the answer is can it gain consciousness, I would want to say yes to that, but we're not there yet.
Okay. This is probably our last question that we can take in. So I think we all agree AI is a form of technological development, and we often talk about the advantage of AI. But we barely talk about disadvantage of AI. Does AI have any disadvantage?
Of course, it does. Like I said, it's a two-edged sword. We want to make sure that it's assured before we use it. AI has many disadvantages. In many cases, some might argue that there's a new field in AI that's called green AI, where we can see that AI is consuming the environment. AI is consuming other jobs, like you asked prior. AI is consuming, multiple other fields. It's maybe replacing. It's providing profit to companies that don't wish us well. So all those technologies, just like any other technology in the world, that is a double-edged sword, and where you have to use it carefully and to mitigate its disadvantages. I want to say the ethical aspect is also a major aspect that we also ought to pay attention to. AI openness is another disadvantage, that AI is not open at this day. Most citizens of the world don't have access to data that can help them improve their lives. So representation is far from inclusive in terms of data science, AI, and access to such algorithms and such libraries. So that's why we always call for open source, open data, open science, open access to everyone in the world, so we can level the playing field and provide a fair technology and provide a fair evolution to all of us.
Yes. We apologize that we cannot offer all your questions. Okay, but thank you for your question. Okay, thank you also for Professor Batarseh for answering those questions and for the great presentation. It was a pleasure to have you with us. So this concludes the webinar for today. Thank you for participating in today's webinar. We hope you have learned and enjoyed this presentation. And now I would like to pass the session to the committee.
Thank you.
Thank you, Dr. Feras Batarseh and Dr. Kardi Teknomo for the awe-inspiring session. Personally, joy from this event. After debunking all the myths, we can conclude that we need high assurance data, especially for public policy implementation. And personally, since I am an IBM student, I just knew that all policymakers are all interconnected with all of the world's economy and its management, including imports and exports, laws and restrictions. And from the Q&A session, I learned that AI is another disruption in our era. And we as university students need to develop our skills that are irreplaceable by AI and also learn about AI itself, of course. I also hope through this short Q&A session, the audience will be able to expand their knowledge regarding AI in public policy.
Yes, I agree, Timothy, especially considering how data is the new oil and how we need data-driven policies for accurate outcomes and benefits. Today's public lecture has provided such great enlightenment. So to commemorate today's event, let us all take a virtual picture together.
So we'll kindly ask the creative division to lead the documentation session.
Good morning, everyone. For those of you who want to turn on your camera, you can turn on your camera now. I will wait. Sure. For all the participants and everyone, please hold your smile for a few seconds because I will be taking a picture of a few pages. So please be patient. Okay, smile for the camera in 3, 2, 1. Please hold. Okay, thank you.
Okay, thank you, creative division.
Ladies and gentlemen, distinguished guests, with the photo session, we have finally reached the end of this event. But before that, we would like to announce our 3 best questions winner. Congratulations to Emmanuel Sibrani, Stanley Irwanto, Amadeus Moses Wiratmoko. The committee will contact you shortly regarding the prize.
Okay, once again, congratulations to the 3 winners with the best questions. On behalf of the committee, we would like to once again thank Dr. Feras Batarseh for joining us and giving us his knowledge about artificial intelligence, and to thank all parties that have been involved in the success of this event.
So please allow us to close this event in a prayer as well, and I will lead the prayer in a Christian way. Let's pray. Dear Lord, thank you for today's webinar. We pray that the insights Dr. Batarseh has given us may be useful for us, and please bless us all. In Jesus' name we pray, amen.
Amen.
Okay.
Before we close our event, we would like to remind all of the participants to please fill in the Regis Out form that has been sent through the chat section before leaving the Zoom meeting. Once again, I'm Timothy Christian from IBM Batch 20.
And I'm Gloria Joy from IBE Class of 2020. We'll see you all in the next event. Bye-bye.
See you, everyone.
Thank you, Dr. Batarseh. Thank you
Thank
very
you,
much.
everyone.
Yeah,
Thank you
bye-bye.
very much, Doctor.
Thank you, everyone. Thanks so much.
Yeah.